or listening to it at a future date. This is the first time that I've been the presenter for one of these, so I'm excited to be able to share with you what's been going on the last couple of months, what we're seeing this month, and then what we'll be seeing looking into early 2021. So these webinars are very much a collaborative effort. You saw on the previous slide a lot of the logos of the partners that contribute to the content and information that I'll be showing, from state climatologists to regional climate centers to the National Drought Mitigation Center. Our next Climate and Drought webinar is scheduled for Thursday, January 21st, same time as this one. The presenter is to be determined at this point. If you want to sign up or access future webinars, we have the link here. And then the High Plains Regional Climate Center and the Midwestern Regional Climate Center, both of those host on their website the recordings of the past webinars if you ever want to view those. So the general outline for the webinar today is I'm going to overview what we have seen in terms of temperature, precipitation, and drought. Probably next month's webinar, there will be more of a 2020 in review, but this time I'll just be reviewing the September, October, November period, and then this month. Then a little overview of crops and soils. Even though we're not in the heart of the traditional growing season, there is some stuff to report there. Some brief overview of what we've seen so far this season in terms of snow, what fire risks are, rivers and lakes, some impacts, notable events across the central region, and then I'll finish with the outlooks, particularly pertaining to La Niña, short term, the winter season, and even a little bit of the early spring. So starting off with recent conditions, what have we been seeing the last couple of months? So I'm going to start with a couple of slides that overview temperature. The first one is the September, October, November, that 3-month period. And this map shows how each state ranked over a 126-year period. So the largest number possible would be 126, and that would be the record warmest 3-month period. And you can see for the eastern part of the central region, the shading is in a light pink or light red, indicating that it is above average, whereas the western part of the central region, until you get to Wyoming and Colorado, fell in the near average. Now that's somewhat of a misleading message because it looks like the 3-month period was very normal, which mathematically and statistically it was, but what we are not capturing in this is the fact that October was quite on the cooler side and November was on the much warmer side. So when we blend those two types of extremes of those months, we end up with a very neutral picture. So I just wanted to call that out, that even though it looks like there weren't too many extremes, it really is because we had quite wide swings in temperature extremes for at least 2 of those 3 months. If we just look at November, you see, and as I mentioned previously, November was warmer than normal, and in terms of how it ranked, we're seeing it in the much above average or more oranger colored throughout most of the region. And so this is where we offset what was cooler for October. However, there were no states that actually met record warmest for November. If we look at just the last 30 days, again, we see that temperatures, and this is the departure from mean in degrees Fahrenheit, that it hasn't been too extreme except for up in the Dakotas. We were reaching more in the 7 to 11 degrees above normal areas, but otherwise throughout most of the region, with the exception of parts of Wyoming and Colorado, we were several degrees above normal just for the last 30 days. So that warming trend seems to have continued and is going to continue into December. We'll see near the end of the presentation. Moving on to precipitation, similar maps that I just showed for temperature in terms of layout, where the numbers on the state indicate how they ranked over the 126-year period. For the 3-month period, September through November, You'll see a lot of states are shaded white, meaning that they were near average in terms of the amount of precipitation received. The western part of the region, though, is a little bit drier, and we'll see that showing up in the drought maps because this dryness that was occurring for this 3-month period is having longer-term impacts going into December. And then Ohio just sort of stands out in our region as they had precipitation that was above average. If we move into just what last month was showing, again, we see precipitation amounts that are near average across most of the region. The thing that sticks out like a sore thumb is North Dakota here, where it's interesting how they fell in a much below average area ranking for precipitation. And then Colorado, Wyoming again are being highlighted for November. Over the last 30 days, approximately, when we look at the percent of mean, so how the amounts of precipitation across this region compared to the mean 30-year period of 1981 to 2010, where the 100, the value of 100 would mean that we were right there at what the mean value of precipitation was. So any of the warmer colors, particularly the golds and the reds, indicate that we were much below normal, the percent of mean. So we're talking just 5% of what is normally experienced over the last 30 days. What's interesting, though, note is for Colorado and even Kansas, it's the southeastern part of Colorado and southwestern part of Kansas. They actually have recently been getting quite a bit of moisture. So that is helping for some of the repletion of the soils, but the northern parts of the states are still lacking. Moving on to drought, just to show since the last month where there's been changes of drought categories using the U.S. Drought Monitor levels, where there are warmer colors, or actually where there's gray, there really hasn't been any change since over the last month of drought categories. Where the yellows and the golds are, that means that drought has gotten progressively worse. And then anywhere where you see the light greens, that means there's been some improvement, a one-class improvement. So while much of the region is in drought, because there's a shade of some sort, we do see that drought does seem to be intensifying across a large part of the region. To look at where we stand today across the northwest of the Weather Service Central region, we really start to appreciate the states that are getting hit hardest by drought conditions. Particularly Colorado is standing out. They are in D4. This is the most exceptional level of drought. This could have an impact on things such as their snow ski season, but they also really count on the mountain snow and water for water resources. So we're going to want to keep an eye on that to see how long that intense drought situation persists. Previous slides, I noted that North Dakota was lacking in precipitation, so we see that that has some of the darker gold, orange, and red colors in there. But when you look at the full region, you see that the eastern states seem to be improving over time. There's not too many regions that are experiencing dryness. In fact, it's just like one swath that's kind of going through Illinois and Indiana. But most of the western part of this region is experiencing some level of drought. If we zoom in closer to the high plains states, I just wanted to leave this map up for a few minutes so people can appreciate the extent of how much of this area is not just abnormally dry, but really almost all these states have some sort of shading, but the extent that is in D3 and D4. Moving on to the next topic of crops and soils. So as I mentioned earlier, there's not too many crops going on, but winter wheat is always something that we watch at this time of year. The top soil moisture, we're going to look at soil moisture percentiles and then soil temperatures. So fairly quickly, this is the status of winter wheat, and the top left map is showing the percent of winter wheat that is good to excellent. And then you can almost think that the bottom right is given the flip story of that is what is the percent of poor to very poor. So depending on how you want to look at this, you can see the situation. In brackets below each number is the change from last week. So if we focus on the map in the bottom right, so the percent that's poor to very poor, we don't want the change over time to be getting worse, because that would mean that there's a greater percentage that is poor to very poor. If we look at the states on the eastern part of the region, so the Indiana, Illinois, Missouri, and even Arkansas, we see that the change is decreasing, meaning that there is the percentage that's poor or very poor is decreasing. So that's a good thing. But if we look at states such as Nebraska and South Dakota, where it is a positive change, that means that we are increasing in the percentage of winter wheat that is poor to very poor. And so this is going to have an impact on food availability for livestock. We count on that winter wheat. Do we have to bring in that hay or food from elsewhere? So we do want to watch these numbers and hope that they will improve. For topsoil, this is representing again by state. This is showing the percent short to very short. So similar to the map that I showed on the previous slide, when we look at the number in brackets, we really don't want to see a positive number in the brackets, because that would indicate that the topsoil moisture is worsening. We want to see the numbers be negative. So it's interesting how there's almost an even divide between the eastern states and the western states, where for most part, the eastern states, they are improving. Their topsoil moisture is getting better. And we're seeing that same spatial east-west pattern when we look at drought maps, when we look at precipitation maps. So it's all linked together, whereas the western states, we're seeing a few that have been increasing, which means that they have a greater percentage that the topsoil moisture is not very high. When we look at soil moisture over a volume depth, and in this case it's from 0 to 200 centimeters down into the ground, we look at that volumetric soil moisture and where is the percentage compared to what we expect it to be. If we compare this to the legend at the bottom, anything that's gray is, we assume, is fairly typical. That's what we would expect. And then anything that's in the warmer colors, the yellows, oranges, and reds, that means that the percentile is actually below normal and perhaps of concern. What is very interesting here is you're not seeing too many yellows. I mean, throughout most of the central region, we're seeing warm colors. So it's not just in the slightly dryness, it is very dry. So the really strong dark red, that indicates that the soil moisture percentile is less than 2% of what we would typically expect. So this could be a concern. Hopefully with the next couple of months, if we see enough precipitation, whether it's in snow or rain, that will help improve the conditions, but it will be something to take into consideration as we get closer to the growing season next spring. For soil temperature, this is an indication often of how deep the frost layer is, the frozen soils are. If the points, the symbols throughout this map are white. So if we look at North Dakota, all of the symbols there are filled in with white as opposed to black. That means that those stations at a 4-inch depth under sod or grass have already gotten at or below 32 degrees Fahrenheit. So they've already experienced freezing temperatures. However, as you look throughout the rest of the central region, we're not seeing too many freezing stations. Certainly there's a few in the western parts of Nebraska and Kansas and right on the Colorado-Wyoming borders, but the rest of the region is still waiting to have the temperatures hit freezing. I'm sure there's some isolated locations based on soil type and local environments, but from this, what we're seeing, even with the overall color shading, temperatures, and I pulled this a couple days ago, was still in the low 40s, upper 30s. All right, moving on to some different types of parameters such as fire and snow, rivers and lakes. I wanted to start off with this accumulated winter season severity index, otherwise called the AUSSIE. This is an index that combines the amount of snowfall and temperatures going across the winter season and compares it through climatology. Because when we think of how severe a winter is, it's not just how much snowfall has fallen, but how bitterly cold it got as well. And I pulled this map just yesterday. The reds are indicating that so far, now keep in mind we're pretty early in our winter season, the stations that are colored red are very mild. So and that we can support by thinking about the warmer than normal November that we've had, and even December for the most part has been warm. So with those temperatures and the lack of snow throughout much of this region, the AUSSIE is showing that it's mild. However, note that as we move westward, the colors start to progress from red into oranges to yellows. So the AUSSIE is showing that we're getting close to average in the high plain states to even severe up in the Wyoming, Colorado states. If we look at how much snow has fallen so far, just over the last 30 days, the map on the left gives the total accumulated snowfall in inches. So the darker the greens into the blues are higher amounts. Where there's gray, there's no stations that have observed snowfall or just a trace at that point. And if we want to see how that compares climatologically, that's the map on the right, where it takes the amount of snowfall and compares that to what the average amount of snowfall is for the 30-year period from 1981 to 2010. So I prefer to often look at the map on the right, because what I see is a lot of oranges, yellows, and reds, and the 100 value, the 100th percentile, is right there at average, essentially. So the whole region seems to be falling behind on what is typical for the last 30 days across the central region. The only exceptions, again, and this is somewhat interesting, is if you look at southern Kansas and southeastern Colorado, they are well ahead in terms of snowfall. So typically we think more snow starts in the north, less in the south, where in these states, and particularly Colorado and the mountains, they're seeing that more snowfall has occurred in the southern part of their state than the northern. For snow water equivalent, and I apologize, the numbers throughout the map are a little small, so I tried to enlarge the legend with this off to the left so that maybe you can focus more on the color shading than the actual numbers. This is looking at what the snow water equivalent has been with December 16th, so yesterday. And the key is, again, if we see any sort of oranges or reds, we are falling behind what we would like to see, or what is the percentage of normal. The greens mean that we're kind of right in the ballpark of average, so that's okay. It might even be nice to see some blues in there every once in a while, but sometimes if we get too wet or too much snow water equivalent, then we have to be concerned about flooding when the snow melts. I've highlighted in red the approximate area of the Missouri River Basin to give an idea, because this is the area that we're focused on more so than the rest of the western states that are shown in this map. If we look at mountain snowpack so far and the water content, here are time series graphs for 2 locations. So going along the bottom x-axis, those ONDs, those are October, November, December, and the different lines are representing years past. So the thick red line is what is averaged over that 30-year period, and then the other lines might show the worst year and the best year. The solid blue shading that starts off on the far left and has progressed about halfway through December shows where those 2 locations are at. And even though they were progressing fairly typical to the others, keep in mind it's early in the season. They're right now both below where the red line is, meaning that they are tracking slightly below normal, but it's still too early in the season to be concerned. But this will be something that folks will keep an eye on to make sure, because again, this is a major water resource for this part of the country. Forest fires, we often don't think of forest fires this time of year, but I know the last couple webinars were highlighting those very large fires that were occurring in Colorado and even Wyoming. There were brush fires that were occurring during harvest time. So I just wanted to show this map fairly quickly, giving an indication that the fire danger across most of the region is low to moderate. Those areas that aren't even shaded either don't have stations reporting or this isn't typical for wildfires. And this time of year, if there are, it might even be more forest related because the fields have been harvested. But the good news is at this point, our risk of fires occurring, wildfires occurring are low. But you'll notice on the right in the bullet, I do have it saying that because of the drought that's going on this year, and we typically see windy conditions occurring throughout this winter season, that should ignitions occur, there could be some very erratic behavior that we see, meaning it's moving very fast one day and changing directions another day. So that's not to say that we should lower our guard and not be concerned about wildfires, but that the risk is quite low right now.
And one other thing about fires, just to say, it's not all about forest right now. A lot of grassland is under, as you were mentioning, those drought conditions. And so there is concern, or I'd say heightened concern, a little later in the year because there's not a solid snow cover, which you're going to cover and all that stuff, across a lot of the plain states. So, you know, it's an extended season, if you will, to some degree, until we get some snow.
All right, thank you, Doug. Moving on to river levels, this is a time series chart again where you have months along the bottom x-axis and trying to see where the Missouri mainstream reservoir status is. It's noted on the map that we are here, so the red line doesn't go all the way to the right that the others do. As is somewhat expected, we are finishing out the year very similar to where we did in 2019 and 2011. However, this is still slightly above average. So this will be monitored as well to see, is this going to increase or decrease based on the amount of precipitation we're going to hopefully see in the next couple of months. As we look at just average day stream flow over the last 28 days across the country, we'll see a lot of greens in there. There's with the freezing streams up north, and the gauges can't really report very well on stream flow. So we're going to see fewer information from the northern states. But if we look down in the more Midwestern Great Lakes states, most of it is green. I don't know if you remember way back in the beginning, I showed the current drought monitor map, and there was that band of abnormally dry conditions to slight drought conditions that ran from the middle of Illinois up into northern Indiana, and that's very well being reflected with the stream flow as well. Great Lakes, there's been a lot of interest in the water levels and the temperatures of the Great Lakes this year. Most of them have been running high, well above their long-term averages. This is from a monitoring site at Lake Superior. The key is down in the bottom left, but if you find the darker blue line as opposed to the light blue line, the dark blue line that's jiggling back and forth, that is the daily levels for this year. And it is on the higher end of the graph, meaning that the water levels aren't record at this point, but they certainly are close to the record. The black line, the blue cyan lines are showing where the historical records are, but they are starting to lower, which is typical for this time of year. As we look at all of the Great Lakes together, you'll see, well, it's hard to tell on this map, but there is very little freezing at this point. The only lake that has any significant ice cover is Lake Superior, and I'll show that more in a future slide. But in general, the temperatures of the lakes have stayed warmer. And the impact that this could have is as cold air passes over the warmer lakes, that cold air is going to thirstily soak up that moisture and could induce quite a bit of lake effect snow for a while. This is comparing what's going on this year in the Great Lakes, which is the map on the far left, with a comparison to what happened last year at this time in 2019 and then in 2018. So again, the color shading that we see over the lakes indicates the temperatures. The bluer the colors, the colder the temperatures. So we see in 2020 that the colors across most of the lakes are on the green side, with the exception of Superior. So if we compare that to the previous 2 years, that puts us into perspective of how much warmer it is at this time compared to the last 2 years. Even Lake Superior, that is obviously colder than the other lakes, it is still running warmer than it was in the previous years. If we look at ice concentration, again, like I said, there hasn't been too much ice coverage, which again, we're very early in the winter season, but if we compare the ice coverage that we have so far in 2020, which is that blue blob in the far left map, with how much ice coverage there was in the previous 2 years, you see that we are a little behind, and that of course is connected to the warmer temperatures. Moving on now to impacts and notable events across the region. With the drought, Illinois has already had some water conservation efforts being requested. Where the request is happening is at a location that often tends to precede where other water conservation efforts occur. So one could say that this is that canary in the mine that is giving a heads up warning that if we're starting to see concerns and having to think about water conservation at this location in Illinois, and it's kind of in the central part of the state, then it is giving a heads up to surrounding areas that they could soon follow. There's also, because of the drought that Illinois experienced, a lower soybean yield. For states such as Wyoming and Colorado, I mentioned previously that they were dealing with very large, expansive fires this last year. And while those fires have been contained, they're now having to face the problem of the lack of cleanup. So when the snow falls and you have outdoor recreation going on, there are fallen trees and twigs that could be hazards to people that want to spend time in these country areas. Also, with the lack of vegetation, there could be concerns of increased runoff and perhaps even mudslides depending upon the location. Over across the whole region, we've seen these low subsoil moistures, and so that could raise concern. And when we hit planting season, we don't want the ground to be particularly muddy, but we don't want it to be so dry that the seeds won't have anything to respond to. So at this point, we are seeing that the soil moisture is low, but hopefully it will raise a little bit more before planting season. And I wanted to point out, just the picture is just one of the burned forests to show the different hazards. So if you can imagine, say, a foot of snow or 2 feet of snow falling in this area, and for people that might want to be snowshoeing throughout the area, they may not realize all the hazards that are just underneath the snow. For this slide, the Great Plains, I mentioned that winter wheat overall is in poor condition, and so what we're seeing in some states, for example South Dakota, is they are having to bring in hay and water from outside the region because they just don't have a local supply that's strong enough. The drought and warmth that has occurred across particularly the western part of the central region is causing stock ponds to evaporate faster so that they are lower. In Minnesota, there's been a lack of snow in general statewide for recreation, though this picture here is showing that I believe almost all of the lakes, many of the small medium lakes in Minnesota, has frozen over. So people are enjoying the ice lake part of the recreation. They just don't have the snow part for recreation. In terms of significant periods when records were broken, these are 2 weeks that occurred since the last webinar that showed where the daily high temperature records were broken. The triangles that are red indicate that the high temperature for the day broke a record at some point during that week's time. And then the pink triangles that point downward, that means the low temperature for that day was a new warm record. So we were seeing quite a few overnight lows that were high, if you will. And then the week of December 8th through December 14th, many more records were broken there. And that both of these maps show the warmth that has been experienced over the last 30 days and how it's not just been above normal, but record setting in many locations. If we look at snowfall, there were a couple of periods when snowfall records were broken for either for that month or the month of to date. So the map on the left is just showing the number of snowfall records that were broken when you consider total snowfall for November. And then the map on the right just shows when we look at total snowfall just since the beginning of December, those locations that have broken new records. So it's not broadly extensive across the region for either of these, but we do have some records that we can boast about. In terms of station extremes, there was a widespread snow event that occurred from November 30th through December 2nd, and it mostly impacted Ohio. The picture on the right shows the snowfall, and this was predominantly lake effect snow in Geauga County, Ohio. But I believe most all of the state had experienced some amount of snow, which wasn't necessarily early for that year, but was probably the first significant snowfall event for the season. And then in Waseca, Minnesota, at this point, they have gone 33 days in a row without precipitation. So I'm not positive if that's a record for the same exact dates that we're talking now, but it is significant. This is something that is unusual for that location. Moving on to the final section of the webinars is the climate outlooks. So I'm just going to jump right into it because of time. We are still under a La Niña advisory. There's a 95% chance that this La Niña is going to continue from January into March, and then I'll show in the next slide that we expect this to transition to more neutral. And this map, you know, first time I look at it, I always get confused because I know it's the Earth, but if you focus on the solid gray areas, that's actually the land. So the colored parts of this map is the ocean temperatures, and then you can see North America kind of in the top right and South America down below. But if we look at the forecast, so this is a kind of a crazy, noisy graph with lots of lines on it. Running along the bottom are 3-month periods. So the ASO on the far left represents August, September, October, and then we're at October, and then October, November, December. So we track what this index, which is measured across the Pacific Ocean, is at, and then they run a whole bunch of different models, and you can see the list of different model acronyms on the right, and each one has a different outcome. But if we put all of these together, we get the gist of, well, if they all are talking about moving, say, up, then that's giving us the message. The zero line, the solid black line, is kind of our threshold between is this a La Niña or an El Niño. So right now we're in the negative side of that. All of the lines, all the models are below zero, meaning that that is more of the cooler or La Niña phase. But you can see as we approach March, April, May, June, July, all of the models seem to be tending close to that zero. So we don't expect the La Niña to stay particularly strong much further past March or April. What does this mean? Well, I looked at this one site, and the URLs for all these are down at the bottom of the slides. The map on the left shows the January, February, March temperature during La Niña and where there's an increased risk of warm or cold extremes. So a couple caveats with this. This isn't a perfect story, so this isn't the perfect forecast, if you will, and the La Niña years don't go back too far, maybe only to the mid-1990s. But we see across most of the central region, there's very few locations that are shaded, meaning that typically the variability essentially in terms of temperature from one year, from one La Niña to the next, is so not consistent that we don't have a message in terms of where we think it's going to be warmer or cooler. But the map on the right is showing some colored shadings. And what this just means is when we looked at La Niña years going back to the mid-1990s and we combined them together, where there are warmer colors, there was a stronger consistency of drier conditions or dry extremes. So we're already in a drought. We could say that there's an enhanced risk that drought will continue. But on the eastern side of the Mississippi, we see more green colors, and so that might suggest that we expect there's an increased chance or increased risk of wet extremes for this January, February, March time period. Over the next 7 days, there is not a lot of hope for rain or any sort of precipitation, even snow, to occur, particularly on the western part of the central region. The eastern part, sure, it has some green colors in there, but if we look at the legend, we're talking less than ½ an inch over the next 7 days. So the dry conditions that we're seeing, I anticipate, will continue. Moving on to the 8 to 14 day outlook. So this is really for the last part of this month. You'll see that for the western part of the region, there is very strong confidence. A lot of the models are in agreement that the temperatures will be above normal. Along about the eastern part, we think that the temperatures will be near normal. And then there's some consistency for those in the Ohio or eastern Kentucky areas that there's a likelihood that temperatures will be below normal. In terms of precipitation, unfortunately, the story is just increased confidence that the precipitation throughout the rest of the month or from the 24th to the 30th will be below normal. If we look at January, you see that the increased confidence for above normal temperatures is significant through most of the region, with the exception of Minnesota and North Dakota, where there really is no confidence one way or the other how the temperatures are going to be. For precipitation, you'll see a pattern that is very similar to what I showed a couple slides back with historical La Niñas, where there is too much inconsistency from year to year for the western part of the central region, but the eastern part of the region, we anticipate that there will be above normal precipitation. Moving on to the January, February, March 3-month period, that temperature pattern continues. And the precipitation pattern, for the most part, continues. We get a little bit increased chance of above normal precipitation encroaching from the north, but in general, we see this east-west gradient where the western part of the region is too uncertain or dry in terms of precipitation, but the eastern side, we believe, should have confidence of above normal. And then the April, May, June. So this is now planting season. We're trying to figure out how bad or good it's going to be. Temperatures, similar story, where the lower Missouri, Mississippi, and Ohio River basins are anticipated to be warmer than average or warmer than normal. And then precipitation, the eastern part of the region, there's increased confidence that it will be above normal precipitation, but to the west, there's just too much uncertainty across the models to say what the precipitation is going to look like. For the seasonal drought outlook, so this is for now through the end of March, the brown areas show we expect the drought situation to continue, and the gold areas where we think that drought will develop or even intensify. So again, we have the strong east-west gradient across our region. So in summary, the short-term outlooks are showing the high probabilities of above average temperatures. And in fact, the confidence is so high across all the models that I wouldn't be surprised if we saw some records being broken, and below average temperature, below average precipitation. The winter, the rest of the winter, the above normal temperatures, enhanced chances for that, mostly in the lower Missouri, Mississippi, and Ohio basins, and then leaning towards above average precipitation on the eastern half of our region. Continued drought across the high plains, and so this means that that soil moisture that's already poor to very poor is likely to stay low heading into the spring. And then we are in a classic La Niña signal, but what that means is too much uncertainty for the temperature and precipitation. However, we do anticipate that with the La Niña, the eastern part of the central region, so around the Great Lakes, Ohio Valley, is likely to be wetter than average. So with that, there's lots of links up here on where the content of the webinar, I got the information and the maps from. And I will end it here with my contact information along with those that are the other key partners of this webinar series. So with that, I'll stop and see, Doug, if you have any questions or if you've seen any.
Oh, there are questions. Hold on just a second. Okay. So thank you very much, Beth. That was an excellent presentation, covered a lot of bases because we have to in this. There were a number of questions. We tried to answer some of them as we went along, but I will help. I'll get them out there again for you and Dennis and myself to help answer. One thing I want to say before we get going is that this webinar series will continue next year. There's always a concern if I can carry it over in the software, and yes, I can. So those of you who signed in do not need to re-sign in again. I'm pretty sure this is all going to work. In January, beginning of January, I'll send out a notice, like I often do if you're on my climate list, that you can re-sign, or that, on January 21st, we'll have this, the next speaker and all that stuff. But so suffice to say, if you're signed up now, you're going to continue to get bothered with this webinar series. So we love having you participate. Now, on to the questions. We had a question about the Pacific North American pattern, PNA pattern. It's called Pacific North American pattern, I think is what Benjamin was referring to. Influence the warm and dry weather in the northern CONUS, and there is a number of things besides that, and it's something we should probably talk generally about. Beth also mentioned all that snow down in southern Kansas and Oklahoma, and how unusual. I mean, it should be in North Dakota and South Dakota, maybe Nebraska by this time, and certainly places to the east in Great Lakes and all that business. And there is some, but it's not much. So why is this happening? Why are we staying a little warmer, or a lot warmer in some cases, than usual? Several things are going on. None of what we say is the complete answer, but it's sort of some of the answer, I guess you could say. One of the things, just very quickly, is that the pattern hasn't been very what we call meridional, which means a lot of north-south movement of air. It's been fairly flat, which means zonal flow, which tends to mean relatively warm. Those systems that are coming in and affecting Kansas and Oklahoma, we've had a few of them, and some of them have dived out of the Rockies and things like that, are sort of cutting through or cutting under that that main jet flow or jet stream flow to the north. So we haven't seen the Arctic air like we did in October. And Dennis, I don't know if you or Beth want to expand on that at all.
No, I think you said it well, Doug, that when we think about these other teleconnection patterns, their influence is really how much storm systems will be coming down from, say, Canada, or coming up from the Gulf of Mexico. And it just seems like lately, and we could be in the sustained pattern, the storms aren't coming from Canada or the Gulf, they're more coming just due west and moving eastward across. And so with that, we seem to then have this strange lack of storms for the most part.
Yeah, and the systems have come through, at least in the Kansas City area and places around here, are relatively dry. That all in all isn't that unusual. The northern plains and a lot of places sort of between the Rockies and, let's say, the Great Lakes don't get incredible amounts of moisture this time of year anyway. So when you see 5% of normal precipitation, you're really not talking about, obviously that's a little bit, but we're 5% of normal precipitation over places. It's not that much that we're missing, if you will. That said, it's all important, right? It's all important for next year and increasing the soil moisture profile. So, Dennis, anything to say about the Pacific North American pattern teleconnection?
Not right now.
Okay. One other thing that there was a question, and this is important always to remember when we look at 30-year, or when we look at averages and normals, when we show all those maps of averages and normals and things, they are calculated off a 30-year, the last 3 decades of averages, as opposed to the entire climate record, which dates back to 1896 or so. Now, that's how we compute averages in climatology, and we're going to recompute those in this year. Sometime this year, we'll have the next 30-year period from 1991 through 2020. Okay, and yes, it will be a warmer average for the most part in most places. Precipitation, I'm not even going to try to estimate what that's going to be. Depends on where you are. But Dennis, did you have any more you wanted to say about that?
No.
Or Beth?
That's
Okay.
I mean that's a U.S. and World Meteorological Organization standard is
Right.
a 30-year climatology. Eventually, there is a possibility we could do running 30-year averages, so it would update every year. But the current standard is to update the end of every decade.
Right.
Yeah.
It helps with consistency from year to year, and certainly for month to month to do it that way. And plus, it recognizes, if you will, a changing climate. Slowly if you're human, fast if you're an ecosystem, and lots of other things. Okay, Brian is shorting. Okay, the period of record, I think Brian was trying to say the period of record on the NASA soil moisture image that you showed, and you can go back to that, Beth, if you'd like, is a relatively short one. And so all I'll say to that is that maybe it compares pretty well to some of the other soil moisture modeling that we have available to us. So that's a pretty good indicator of where soil moisture is short, and not it's not the only one. It's not the only image that we have for soil moisture. There's several of them.
And
Go
Doug,
ahead,
yeah, I did some checking with some of our soil moisture colleagues, and it's not clear what their period of record is included here. I would assume from a percentile basis they have done something to lengthen that using modeling or whatever, but we can't say specifically right now. We have been watching this during this summer, and it has some, we like it. We think it seems to do reasonably well.
Okay, there was a question about winter wheat damage, and anybody want to say anything about that? And in regards to below normal temperatures, freezing temperatures, which we had in October, which were pretty severe. But go ahead, Dennis.
The temperatures have not been extreme enough yet to probably add to the issue for winter wheat. The winter wheat's problems so far have definitely been dryness related and not cold related. Now that said, when the cold does come, which we assume it will eventually, there could be some sort of a combined or an additive effect, multiplicative effect between cold and dry, damaged winter wheat, but we won't know that until the spring and see how things come back in the spring.
Okay. A couple observations out of Montana about, thank you, Dennis Longknife, about how they've had several, and this is sort of north central-ish Montana, which you would think would be relatively cold and relatively snowy. They have had some snow and precipitation events, but and temperatures dropping down, but it has warmed right back up again. And so there's a few drifts around, and that's about it. There was one other remark I think Dennis had about grasshoppers can come late, so it was too late to spray, and other species attacked our cover crops. So there were quite a bit. Oh, that's good, Dennis. That's good stuff. I'll have to remember this. Quite a bit of damage to things because of the late impact of grasshoppers and dryness, and impacts on livestock and such. That's okay. And Laura made that remark there, which we covered, and Patrick. Oh, okay. So what about Montana, northern Wyoming for La Niña snow and temperatures? Right. So, as Beth showed, you can go back to January, February, March, if you will. Beth. The outlook, the actual outlook, the forecast.
Oh.
Yeah. January, February, March. Yeah. So again, without going into a lot of great detail, this hasn't changed much from last month. This is a stereotypical La Niña pattern across the nation. This is what we expect to see with a moderate to relatively strong La Niña pattern, which is cooler than normal temperatures averaged over January, February, and March, and where in Montana and North Dakota, and it's iffy as you get down into Wyoming and Colorado, and a relatively wet also conditions. Now, those probabilities on these maps are not super strong. So those are kind of weak, as a matter of fact, in terms of temperature being below normal. Same with precipitation. And when you get over to the Ohio Valley, however, and I know a number of folks are interested in that as well, the correlations are pretty strong when it comes to precipitation and being above normal. Now, how much above normal, we don't exactly know, but that bullseye over Indiana, Beth, is indicative of a typical La Nina. So we expect that basically to happen. Anything you want to say about that, Beth?
No, I think you captured it. Just the uncertainty is pretty strong right now.
Yep. Oh, sorry, John. Could you return to the previous slide with all the URLs on it? Could you go back to it's like the second to the last slide. Yeah. Sorry, hopefully you're still on. And John, if you can't find what you're looking for, feel free to email any of us. We will make sure you get what you want. Are the record warm temperatures in the northern plains and lack of snow cover a result in man-made climate change? Okay, first I'm going to ask Dennis and Beth if either one of them would like to say something about that.
I'm happy with you, Doug.
I'll let Beth go first.
And I've handed it to Doug.
Okay, so Benjamin, I would, if you're saying, is the result of the record or near record warmth over, let's say, the next week or two in places in the northern plains because of climate change, I would say not directly, but it sure is indicative of what we have seen and the trend we have seen over the last, at least 50 years in terms of especially minimum temperatures not being as low as they used to be. Okay. High temperatures also, yeah, we may set some high record temperatures, but it's very interesting to see the minimum temperatures not get as cold as they once did. So I hope that answers your question a little bit.
Doug, let me add in one piece to it. It is possible this is also related to La Nina, because you can go back. The signal for La Nina, especially stronger La Ninas, is not clear cut that it's cold all the time. We have several winters during fairly strong La Ninas that were quite warm winters. So it's almost, in some cases, you have a strong response one way or the other. So it is very possible this is La Nina related too. There are other folks who deal with attribution parts, and it would be great to have them chime in on this.
Yeah. So hate to give you a wishy-washy answer. Part of it could be related to La Nina. La Nina generally, though, means below normal. This is a general comment, and that's what the forecast is for generally cooler than normal temperatures, or at least a leaning towards cooler than normal temperatures during a La Nina. Okay. So, however, we saw 2012 was a great example of how that didn't work out so well during a La Nina year. It was awfully warm, and the result, and I'm not predicting 2012 to be this way. The result of 2012 was widespread drought. Go ahead, Dennis.
Yeah, there were two in the late 90s, I believe 98, 99, and 99, 2000 that were fairly warm too, if I recall those correctly.
That's right. With the relatively high variability in temperatures throughout the fall for the upper Midwest, and the new CPC outlook showing equal chances for temperatures in much of that area, we anticipate continuing to ride a roller coaster of temperatures, particularly considered ongoing dry conditions. Great comment. And I'm going to say yes, based upon what little as far as what I can foresee. You know, we tend to get Arctic outbreaks sometime. And Dennis and I and Beth have been talking about the last few days, and others have been talking about this too, is that we're waiting for we call it the switch to flip. Now, that's not very scientific, but we've seen in the last few years, we'll say relatively warm Decembers or relatively warm Novembers, and all of a sudden, everything changes and it gets cold and stays cold. So far, in all the models that we've seen, and Dennis, I don't know if you want to say any more about this, we haven't seen the switch. Sometimes we never do until it happens. Sometimes it does take us by surprise. But as long as we have this strong jet to our north, sort of, if you will, protecting us from Arctic air, I'm not sure when that's going to happen.
That's really the case. I mean, you can keep an eye on Alaska. When Alaska gets colder than average, then we can watch and see if that can work its way down towards us. But that really has not happened on a large scale. We've had small pieces of cold that have come over us, but really nothing severe in the last 6 weeks or so.
Dennis, do you want to say anything about snowpack and cold temperatures, again, generally speaking, across the northern part of the country?
Sure.
About how that influences, yeah.
Right, and because snow is colder, when you have air moving over that, when you have cold air from the north that then keeps moving over snow-covered ground, that is able to maintain its coldness, so to speak, and work its way further south. When you have bare ground, the cold from the north, if it is cold, moves over bare ground, which is somewhat warmer, and that cold, that cold air mass is not able to maintain that cold nearly as well. And so this lack of snow cover over to our northern areas is influencing that issue.
Yep. Someone comments that Iowa still has snow on the ground. And yep, that's true. And I don't know how much longer that's going to be there. Dennis, short-term forecast?
Should do a good number on it this weekend, I would think.
Yeah, we're looking at pretty warm temperatures. Good question. Are soil frost depths different this year with drier soils and some warmer than normal temperatures?
They should be if we had cold. But again, our lack of cold is not pushing that frost depth too deep yet. It has typically drier soils will freeze deeper more quickly because of the lack of water. Water has a high heat content. It takes a long time to warm it up. It takes a long time to cool it down. Without that much water in the soils, it is able to freeze more deeply. But we have to have a good amount of cold, and we just haven't had that good amount of cold to push that cold depth too far down.
And it is something we definitely watch in the late winter, early spring in terms of depth and thickness of frozen soils. We don't want those to linger. We want those soils to warm up gradually and basically thaw. If they don't, we have a situation like in 2019 where we had rain on snow on very hard frozen ground pretty late March in the year. So all that is a concern, and we'll talk more about that in the coming months. Okay. Oh, there's a little bit more in here. Yep, the warmer and drier weather that we had this fall was great for harvesting. Getting dry and dusty comments from folks. Comment rather than question. Oh, okay. Someone pointed out that the snow photo from Ohio, it's Geauga, spelled Geauga, not Gaiga. We had it spelled. Sorry about that. That was pointed out to us by someone else as well. And then a happy holidays. And don't forget the Arctic oscillation. Oh, that's a great thing. And I just sent, those of you who don't know, is yet another teleconnection. We call them teleconnections. Arctic oscillation, the AO we refer to. I won't go into great depth. I just looked at the outlook for that and looked at it, what happened in December. And it does have a major influence no matter what the La Nina is, no matter what El Nino is doing. The Arctic Oscillation can, if you will, overpower that pattern with its own pattern, which often draws a lot of cold air down into the lower 48, mainly for the eastern half or 2/3 of the nation, sort of east of the Rockies. We just came out of a negative, which usually means colder than normal temperatures. We just came out of a negative sort of situation where we didn't see that happen. So it's not always a one-to-one relationship. And I don't know if Dennis, you want to say any more about that. The outlook is sort of all over the place in terms of where that's going for the next 2 weeks.
Yeah, I'm don't have too much to add, I guess.
Okay. Okay. Thanks, Aaron, for that comment.
Beth, did you have anything else to add?
No. Nope.
Okay, are we likely to see a bomb cyclone this winter? And I think he's referring, Dennis, to your Iowa State team. So I'm going to leave it at that without answering. I'm not. That was Dwayne Voy. And if anybody knows, so Dennis, if you know who Dwayne is, you can.
I know who Dwayne is.
Okay, you can. You can talk to him about that. Thank you all. We really appreciate you coming to these and your great questions. Love them. We'll see you in January, and may the climate be good to you. Happy holidays. And thank you very much, Beth and Dennis, for your help on these as well. Really, really appreciate it.